Good morning, boys and girls, and welcome to the mess hall here at Dr. Jet Laboratories. Today, we're going to continue on in the process of designing the twin JetCat 16. Now, the twin JetCat 16 is going to be a collaboration between Dr. Jet and his viewers. And to that end, I'm taking a lot of what you guys say and I'm incorporating that into this design. And recall yesterday, I did a cross-section through the sponson and looked at some things. Well, I've moved some things around, changed some things. I put some dimensions on it. And you see, there's only one dimension that's really pretty solid. The rest of them sort of follow suit, you know. Why is it 0.937? Well, there's a reason. But I made this a little wider because when I started laying out the 3 view, now here's that drawing here. So this would be looking down at the top of the hall, and this would be looking at the side of the hall. So what I did is I established a length, 16 inches, and then I divided this into threes because remember, you want it to balance at about 1/3. So I want to establish 1/3 early in the design. So here's 1/3, here's 1/3. And what's going to happen on this 1/3, that's where the looking down at the top of the deck bow curve is going to begin. On the side, rather than dividing it into 3 sections, I divided it into 5. 1, 2, 3, 4, 5. And I started the bow curve at 2/5. I looked at 1/3 and it didn't look right. Now that's something I need to talk to you about. I keep saying Steve New and I still are good friends. Steve and I would design airplanes. We'd fly slope gliders at Torrey and, we'd design and build stuff. And Steve went off into the F5B world and wow. And we both used what we like to call the TLAR method for like establishing tail volume coefficients and so forth, how big your rudder needs to be in relationship to the length of the fuselage and the wingspan and the chord. And so we developed the TLAR process, TLAR. And that's where you would look at the drawings and you would say, that looks about right. TLAR. If it looks right, it's pretty close to being right. So the TLAR method has really not let us down. So I'm using the TLAR method on this. When I looked at the side bow curve at 30%, starting at 30%, it just didn't look right. Now I look at it at 2/5, and it looks right. It looks right. So this thing is turning out to look like, it's going to look like a little shoebox. It's going to be just really plain, but it's going to be easy to build. It should be faster than snot. And you can always put a foam top on it and make it look like anything you want. Now, one of my viewers asked, what am I going to skin it with? Well, I have several options, and I've sort of narrowed it down to 1 or 2. Because I'm using all simple curves, and it'll be real easy to determine what axis they're going to be in. For example, you see I established a line here. That's the center line of the drive shaft to the center line of the motor, and that forms a plane on which you will see the curve of your drive shaft, and you can establish this motor mount angle, and then when it moves into place there, you get the other angle, because the motor mount's going to be tilted this way and that way. So that's part of the game, and just some simple geometry. You don't really have to multiply and divide anything and look for cosines and do trig or any of that. You can do it all with simple geometry, which is what I like about AutoCAD. It's basically simple geometry. It's like surveying. There's only two things you can do: angles and distances. You can do angles and distances. You can draw a line between them. You can draw a circle between them, but they're angles and distances. So there's where we are in the design process. Like I said, this is the top of the sponson, and it looked pretty thin, so I fattened it up a little bit. And the construction on this, I am not going to follow the normal, construction things. I'm going to build this thing like an outrigger. They're going to be two sponsons connected with some, carbon fiber booms, and there'll be a wing section in between them. So that's where we are. Stay tuned. We'll have more design thoughts in the future. I've got a couple of other projects I need to use the computer on, so I may not be on this for a day or two. So stay tuned. Until then, jet out. Oh, it is running. Well, boys and girls, I was proofreading or proof viewing that video, and one of the benefits of a stream of consciousness video is you never know where it's going to go. So I started to answer somebody's question about skinning the twin JetCat. And I got into rambling off about all the glories of the accuracy of AutoCAD and geometry, being able to, get everything exact. The point of that is I can laser cut the skins, and as long as I'm working with 16th ply, why not make the skins 16th ply? Make these things bulletproof. Or maybe a better word would be ironcladded. Now, as far as motors go, I got to thinking, and I can't limit you to one motor and force you to buy Steve's really good but not cheap motors. So I'm going to do a drop-in motor mount, and that way, with the beauties of the laser, I can cut a mount to fit any motor you've got. If it's got 3 holes on a 13 millimeter center, I can do that. If it's 4 holes on a 16 and a 19 millimeter center, I can do that. Here's another idea too. I've seen the German guys do this in their carbon fiber motor mounts, and it's cool. Drill holes for the mounting screws to where the screw heads will go through the holes, and then do a circular slot emanating from those screw head holes. So you would put the motor into the mount, turn it to lock it in place, and then tighten up the screws. I can do that in the laser, and it would be perfect. Absolutely perfect. So there's the answer to the skinning question and the motor question. I'm not going to limit you, but I will give you the option to put just about anything you want. Until next time, jet out. Where the hell is the damn button?